University of Minnesota in the on-site sewage treatment program and the Water Resources Center, and is an adjunct assistant professor in the Bioproducts and Biosystems Engineering Department. For over 25 years, she has been conducting research and providing education and technical assistance to homeowners, small communities, on-site professionals, and local units of government regarding decentralized on-site wastewater treatment. Sarah coordinates the research program at the U of M, focusing on issues related to decentralized wastewater, chlorides, and milk house process water. She has presented in over 30 different states and provinces in North America regarding the science of wastewater treatment, including design, installation, and management. Sarah is the president of the National On-Site Wastewater Recycling Association, serves on the NSF International Committee on Wastewater Treatment Systems, and chairs Minnesota's SSTS Advisory Committee. She has a bachelor's in biosystems and agricultural engineering and a master's and PhD in water resource science.
All right. Well, good afternoon, everyone. I will tell you, doing virtual training events is not as fun as being in person. The thing I miss the most is seeing everyone's face. Kind of gives you a good way to gauge how your presentation's going. So I'm going to assume that for most of you, you know little about septic systems. So if you know a lot, some of this will be review. But I'm going to talk about what septic systems are, but I'm also just going to talk about our program a little bit here in Minnesota, and then talk about some emerging issues in the decentralized wastewater world in general. So my email address and our website are on this first slide. So definitely feel free to reach out to me after this presentation or anytime in the future if you have questions or issues about wastewater. And I would just say more broadly, many of you may know the Water Resource Center at the University of Minnesota, but we have a wide range of water professionals, depending on what your question is. I might not be the person, but someone else might. So what we're going to talk about first is what is decentralized wastewater treatment. We'll then talk about how our program works here within Minnesota. And nationally, our program here in Minnesota is really progressive. We're one of the longest standing, most successful both regulatory and education and certification programs in the United States. And then finally, we'll get into those emerging issues and challenges. But this diagram really explains a lot of why I'm so passionate about what it is that I do every day. And that is, 70% of Minnesotans drink groundwater. So unless you live close to a big river in a big city, your water's coming out of the ground like you see with these parcels. And, some of them are individual parcels. Some of them are communities like you see more on to the right of the lake that, a lot of municipal wells pulling up groundwater. And in general, even in Minnesota, we are pulling out more groundwater than we are returning. But the good news about septic systems, when properly designed and installed, we keep the water within the watershed. So instead of a municipality that's pulling water out of the ground, using that within the homes and businesses and sending it to a wastewater treatment plant, all wastewater treatment plants discharge into a lake, river, stream. And so typically, there's a few exceptions if it's going into a lake, but typically that water then leaves the watershed. And we're just really not recharging our groundwater at the same rate that we're taking it out. But septic systems can be part of the solution of that issue. But it also just points out how important this diagram properly treating our wastewater is. Ultimately, probably most of you either with lunch or right now are drinking a beverage. And what we have to remember and consider is that water has been used before and will be used. One of my last topics that's an emerging issue is wastewater reuse. Ultimately, all of our wastewater is being reused. It's just a question of how quickly are we reusing that water. So that's always something to think about, is that we're just recycling our water over and over again. So kind of first looking at what is decentralized wastewater treatment systems. So people call these septic systems, and that's what they are, right? That's what we call them here. But ultimately, there's a lot of different kinds of septic systems. This shows what sometimes is referred to as a drain field or a conventional system. It starts with primary treatment in a septic tank, and Jack alluded to this being like wetlands, in that septic tanks are anaerobic, so the treatment occurring there is under an anaerobic environment. And we can actually, we did some research. Some of my first work at the university 20 plus years ago was using constructed wetlands to treat wastewater. Not very commonly used in our climate here for various reasons. We can talk about more at the end if you're interested. But really, we really do start with that primary treatment that's more solid,
So looks like we lost Sarah real quick there. Sounds like your video went out and the screen share went out. Can you still hear us? Screen's back up.
I'm back.
It's a good thing.
You wouldn't believe this. My cat was on my desk and it closed my laptop.
Yeah,
it's the perils of working at home. I'm so sorry.
Yeah. I can edit that out in the YouTube video, so don't worry. All right.
Oh, that's hilarious. I've never had that happen. Okay, anyway, back to the presentation. So I think I was talking about, this is a kind of a conventional system here that we see. Effluent going through anaerobic digestion, and then out in the soil treatment system is aerobic. So a majority of the treatment occurring, particularly the removal of viruses and bacteria, is happening in that aerobic environment. But the first part of the process, which is the septic tank, has to be working properly for this whole system overall to work. You'll see then as the wastewater flows through that, we'll talk more about this later, but the majority of that virus and bacteria removal is happening in the soil. So with this site, we're able to do that all in the ground, that's where that treatment is occurring, is underneath the system. It's also very common now in Minnesota to have elevated systems, or commonly referred to as mound systems, where we import the soil because we don't naturally have that occurring on site. So kind of going over a little bit what we just talked about, a typical decentralized wastewater treatment system starts with that primary treatment in a septic tank like you see here. And this is every wastewater treatment process starts with this, where we allow sedimentation to occur. So heavier solids settle out into the sludge layer, lighter materials, oils and greases in particular, float to the top. We see about 50%, give or take, solids removal occurring in the septic tank, and that does result in the need for maintenance. You know, every 3 to 5 years, most homes need to have that tank cleaned to assure that we're not building up excess solids. Our final treatment, disinfection, is in the SSTS portion, and what is required in Minnesota is 3 feet of unsaturated soil. There are other options for advanced treatment systems on challenging sites, or when you have challenging soils or larger systems. For example, the largest septic system in Minnesota that I'm aware of anyway serves downtown Afton, Minnesota. So that's in Washington County, and that system is 60,000 gallons a day. That was their design flow anyway. And directly down gradient from that are wells. And so when that system went in, it was required to have advanced nitrogen treatment and actually secondary treatment prior to the soil to assure that when that wastewater potentially reached down gradient wells, it was going to be safe for human consumption. In some areas, rely upon well setbacks and some groundwater dilution to account to meet that nitrate limit, but with those larger systems, that's really not an option. Here in the Midwest, being very far from the ocean, we're not as concerned about nitrogen getting to surface waters, but we're very concerned about phosphorus getting to our lakes. So ultimately, kind of the nutrient issue depends a little where you live. So here again, phosphorus is our limiting a nutrient in most of our fresh waters. So how this looks in someone's backyard is whenever people can, we will see from the structure, which is usually a house, but there are a lot of commercial properties. You think about campgrounds, rest areas, restaurants, if you know, in a lot of outstate Minnesota isn't in municipalities. The wastewater, when possible, flows by gravity. Every once in a while, someone has to have a pump in their basement to get things out of that lower elevation. But then flowing typically by gravity into that septic tank, and when possible, again, gravity to a soil treatment system. So this again shows a drain field type trench system. And the key thing you want to notice is on that far right is from the bottom of the system to saturated soil or bedrock is where we're going to measure that 3 feet of soil where, and it was kind of the most amazing thing to me when I got in this industry is that if you take dirty sewage, million to a billion bacteria and viruses in 100 milliliters of water, after that 3 feet of treatment, the viruses and bacteria are gone. The organic material is all removed. The phosphorus has all been absorbed. We've certainly converted all that ammonia to nitrate, and in some instances, actually denitrified that as well, if the right conditions exist. So this is where if we had easy polling, I would have you all fill out a poll. So if you want to type this into the chat, you can. Otherwise, you can just think it in your head because I'm going to give you the answer. But just from your knowledge, what percentage of homes in Minnesota are served with a septic system? Anyone have a good guess? I see a 24. I think that's what I saw. An 11. Anybody else? Casey's, I'm gonna just tell her right now, she's right? So the right number in Minnesota is actually 32%. So the national average is actually a little lower. So Minnesota is one of the higher percentage states. There are states, if you've ever been to New Hampshire actually has more than 40% of their homes on septic systems. But here in Minnesota, we are right at that 32% number. All right, so a little overview here of some of the information in, oops, I have to go back one here, I missed that. Just moving around faces. The history and statistics in Minnesota. So this program in Minnesota actually started at the University of Minnesota in the mid-70s. So there was a professor in the biosystems and ag engineering department at the time who really was asked, you know, why are some of our lakes getting green? Could it have anything to do with these septic systems? So at that time was right around the time the PCA was forming. So there were rules that were written and there was a voluntary certification program that was started and the University of Minnesota training occurred. And although I did mention it started in biosystems and ag engineering, there was always, and very soon after, the gentleman's name was Roger Mockmeyer. He reached out to Jim Anderson in the soils department, and the two of them really together built our training program. Because at the end of the day, septic systems to me are the nexus of where engineering and soil science meet. So I'm guessing most of you are from the soil science side of things, and soils are a huge part of what septic systems are. So that's really what our training program teaches today, is it teaches typically non-engineers and soil scientists those principles to be able to adequately design and install septic systems across Minnesota. So you'll see in 1996 to the present, that 1996 is where we got statewide rules and statewide required certification. So our certification program is pretty old when you think about it now, starting in 96. And that is really what supports our program at the university. We actually have $0 that come into our program from the university. They actually just take a little off the top. And that's how we do our training program and how we hire the people like myself who work in the program. So it is one of our programs is one of the most comprehensive in the US. Every septic system that goes in the ground in Minnesota is permitted and inspected by local unit of government. So that's typically a county, although there are some cities and townships that do their own program. And also we have about, give or take 20 to 30,000 septic systems that are inspected annually for compliance, like are they good systems or not? And when we look at those systems, we don't just look at are they surfacing, because that is one way that septic systems fail. We also look at how much separation they have. So our understanding of soil and our application of soil science has improved over the years. Our regulations really haven't changed, but practitioners' understanding of soils, particularly redoxomorphic features, has changed over the years. So when we look at existing systems, we do verify that they meet that 3 foot of separation. So every year we collect data about how many systems are in Minnesota, and you can see we have over 600,000 septic systems, which equates to 32% of the households. If you look at how much wastewater is coming out of those homes, that's 42 billion gallons of wastewater every year is being treated by septic systems, which is why, again, it's so important that they be adequately designed, installed, and operated. The last one is by estimates that were done by myself and the PCA, about 25% of those parcels are within shoreland. So, they're meeting that 1,000 foot from a lake, 300 foot from a river. So in more sensitive environments, particularly where removal of organic material, bacteria and viruses, phosphorus is even more critical. So why is wastewater treatment so important? Ultimately, when we use water within our homes, when it leaves our homes, it's 99% water. But that 1% is really important. It's what allows us, as you see the kid in the diagram, to be drinking out of the hose. That water, and it is kind of ironic sometimes to think about that all the water we use in our homes, even the water we use to flush our toilet, is potable drinking water. But ultimately, that 1% that we add to the water really does need to be adequately treated and removed so it is safe to use again. This will result in protection of public health. So we know how diseases and viruses commonly spread. Most commonly, it's from our waste, right? And so if our waste is containing those pathogens, that can spread via water. The added benefit when we adequately are protecting public health, we're also protecting the environment. Nitrogen and phosphorus are still, I would say, are kind of the driving issue now with wastewater treatment. I think we really figured out in the 70s, 80s, and 90s that organic removal and bacteria and viruses were really important. But what's really getting more and more attention over the last decade has been assuring that we're also dealing with those nutrients, which are both, I mean, nitrate is a public health issue, but as we talked about, phosphorus is really important in protecting our lakes, rivers, and streams. So a little bit more about how our systems do this. That primary treatment, the job of the septic tank is first and foremost to catch solids. That means we're going to be decomposing organic material. But there are some solids that go down the drain in our homes, which are inorganic in nature that cannot be consumed by microorganisms. And so the septic tank will store some of those. So we see those layers forming in the tank, right? Our soaps and greases and a little bit of toilet paper. Most of the toilet paper actually disintegrates within the process. Our liquid layer, which is not clean, it's still going to be cloudy or turbid. Some smaller particles will remain in suspension, and then the bottom layer being heavy organic and inorganic material. So if you open up a typical septic tank, what you will smell is anaerobic digestion. You will smell methane and hydrogen sulfide, gases being formed by that anaerobic treatment process. So here shows a little close-up of that septic tank I showed before. So wastewater coming in from the left from our house. On the way in, there'll be a baffle. The purpose of that is to make sure the wastewater doesn't short circuit the tank. Septic tanks are designed based on detention time. So how many days the effluent has to be settled and anaerobically digested. So this is a modern septic tank, and the reason I say that is we have a riser both at the inlet and the outlet, and that those risers are at the surface. This is really critical for maintenance in that the proper way to clean those tanks, the only way to properly do that is through large diameter access, because the sludge, as the name implies, takes work to get off the bottom of the tank. The other thing that more modern septic tanks have, which old ones don't, are baffles and screens on the way out of the tank. So the purpose of that screen on the way out is to further limit the size of particle that gets out to the soil. So the soil is amazing at decomposing organic material, but as I mentioned, some solids that may be present in our wastewater, which I'll talk about at the end, such as microplastics, may not be digestible by soil microbes. So as much as possible, the solids either being decomposed or being filtered out prior to getting to the soil, the longer that soil treatment will function. So again, those are our three layers. So a conventional, and this is a little bit of terminology in our regulations, they're also referred to as type 1 systems. That should be rely on passive soil treatment. So in order for these type 1 systems to be installed, you need to have 3 feet of unsaturated soil. So this could be naturally occurring dry soil. That would allow you to put a trench system or a bed or an at-grade, and I'm going to show some pictures of these coming up. Or it could be by using mound sand, and mound sand is very similar to concrete or C33 sand, if you're aware of what that is. That can be hauled in to supplement any natural soil on site. You still, even to build what is called a conventional mound or a type 1 system, you do have to have at least 12 inches of dry soil. that hopefully does a few things. One, it prevents us in most instances from hopefully building in a wetland. But the other thing it also does is it assures us that even if the wastewater, as it goes through those 2 feet of sand, has been, almost all the way treated, we still need somewhere for that water to go. And we do require, again, in Minnesota, that all of our wastewater stay subsurface and laterally move away from the system. And if you don't have 12 inches of dry soil, that's pretty difficult. As I mentioned, there are other options to further pre-treat the wastewater prior to the natural soil. They're not as commonly used in Minnesota. And I saw a question pop up about microplastics. We are definitely going to get into that a little later in the presentation. So if I don't answer that, we'll talk about it then. So I've shown some pictures of what the trench systems look like. This is just a bad diagram, but a diagram of what a mound system looks like. So where I'm elevating, my treatment system with that clean sand. So I still am going to meet my 3 feet of soil. The reason, again, why we use sand is we can pick sand up from the quarry or pit. We can move it to another location. And because it's relatively structureless, we can, basically, when not using compacting equipment, but by natural construction, can really get it to a similar density that it would be, that will allow for good water movement, good percolation, and good treatment as it moves through that sand. So how we determine what kind of system we need, and you can see all we're really doing with and these are all really standard conventional options in Minnesota, is how far or where you are in reference to a limiting condition. So our 2 limiting conditions we're really concerned about, and which of these are relevant depends where you live and whose property you're on, is either saturated soil or bedrock conditions. And we'll define each of these coming up here. So on the far left, that would be my trench system where I'm actually in the ground because I'm able to achieve my 3 feet below that. The system in the middle being an acrid where I put my rock or distribution media right on the surface. And then finally on the far right is a mound system where I'm hauling in that sand to achieve my 3 feet, having at least 12 inches of dry soil. So here are just some images showing what this can look like. So the first one that just popped up is a rock trench. The purpose of the rock, or I'm going to bring up the next one here, that's actually called a chamber system. It's recycled plastic that's used. In both of these instances, the purpose of the media is just to spread out the wastewater. It's not doing the treatment for us. All of the treatment is really occurring in the soil. So just 2 different ways to do that. So you can see these systems are relatively shallow. They generally have at least 12 inches of cover just to help from traffic over the top. We never want traffic, but it can happen. A little bit of freeze protection, but we do certainly know that frost is going to be often deeper than these depths. The one that just popped up, that is actually referred to as a bed system, basically a wide trench. The one there on the top right now is called an acrid. So we have now kind of scarified the surface. We put the distribution media right onto that soil surface. Here's a mound system during construction. So you can see we brought in that sand, elevated that mound, and then basically dug a bed system down the middle. And that is a finished mound system in someone's backyard. So how do we determine what type and size system? Well, what type is allowed is the first thing to consider is how much pre-treatment prior to the soil. So really today I'm focusing on systems that just have a septic tank as primary treatment, but there are advanced systems. This is where a constructed wetland could play in, to a pre-treatment system. The second factor is how much natural unsaturated soil you have. Then the last variable here are your soil characteristics, which are color, texture, and consistency. So, and we'll particularly get into redox features, but for all of our septic system designs, we are doing morphological descriptions of the soil. And the most limiting factor for how deep that system can go in is soil color. There are some texture limitations as well, and I'm sure you certainly all know that often wet conditions and clay are something you find together, but we're really using soil color and occasionally the permeability of that soil. So if we have very heavy clays, there is no option to put a trench system in. Lastly, I'm going to finish this and then we'll get to that question that just popped up. The system size, how large the system needs to be, is based on the flow and gallons per day. And for residences, that is based on how many bedrooms are in the home, because that ultimately sets the maximum, well, it should set the maximum occupancy of a home. The tank sizing can be impacted if they have a garbage disposal within the home, or if they are pumping raw sewage, because once you start pumping raw sewage, you start grinding stuff up into little pieces that don't settle out as well. The last thing, and probably the biggest variable that impacts system size, is the soil type. We all know what would happen if you took a cup of water and you dumped it on sand. What happens, right? The water runs away. You take that same cup of water and you dump it on clay, and or even a loam, right? A little bit it's going to pond, it's going to take more time to soak in. So as our textures get finer, the amount of area we need for that wastewater to be absorbed in particular goes up. And ultimately, our septic systems are really balancing treatment and dispersal. They have to do both of it. They have to treat all the contaminants, but they also have to disperse that water back into the environment. With that, Jack, do you want to ask that question that just popped up?
Sure. So in addition to the vertical distance of 3 feet from the saturated soil, are there also horizontal distance requirements from wetland boundaries?
So there is no official statewide setback from a wetland. You could run into local jurisdictions that require a setback, but the state code only has what would be defined by any sort of wetland delineation potentially, because ultimately if you have hydric or wet soils, you cannot build a conventional septic system in those soils. We do have lake setbacks, so when you're getting close to that wetland lake line, you may have an official setback, or if you have wetlands that are very close to a lake, river, or stream, you may then have a setback from an ordinary high water amount, but there is no state required setback from a natural wetland. It's a good question. So getting into the variables a little bit more specifically with you all, since you understand soils more than most people I get to talk to. So the critical soil characteristics we're designing on, the most critical one that affects the system as we're talking about right now is the soil wet. So we are, when I talk to property owners, we talk about grays and reds, but we're really identifying, are we dealing with redoxamorphic features? So looking at the Munsell color, the specific page I have here, and this is true no matter what page you are, is if you're in those 2 left columns, if you have a depleted matrix, and we should be avoiding the topsoil because it does get a little bit more complicated when we're in those topsoil colors. That organic staining can certainly make it more difficult to see redox features. But when we have depleted matrix, when we have redox features, that is again what we are using to define that we have a water table. So that may be a periodically or seasonally saturated water table. It may be a permanent water table. Our regulations do not care. As long as we have a depleted matrix, we have redox features, any of those will make that soil unsuitable for extended periods of time throughout the year and require us to stay 3 feet above that. So that is how we determine saturation, is by redox features. It takes those extended periods of time for these to form. So again, generally speaking, when we see very gray or depleted matrix, the soil is wet or saturated. If all the iron has left, it's very wet. If it's gray with red models, it's typically more of a seasonal saturation, maybe in the spring or the fall of the year. But groundwater is groundwater. We are generally talking about perched water tables versus permanent, like what I would say is more the regional water table. But some of our septic systems around lakes and particularly sandier soils, we may be more dealing with a regional water table. but very often we're dealing with water that's held up higher up in a soil profile. The other limiting factor in soils is bedrock, and we have kind of a, I would say, odd definition of bedrock. And what I mean by that is most of the time when people think about bedrock, they think about like along the North Shore where you have very little soil and it goes straight to bedrock. But our definition of bedrock is anytime you have more than half of your soil composed of rock fragments, and rock fragments are defined as anything greater than 2 millimeters, we are not going to count that to soil treatment. So typically this, you can envision that augering or boring is very difficult in these situations. So typically a soil pit can really aid in defining whether or not we are dealing with bedrock. And in some sites it's super obvious, but when you get close, when you're dealing with rock fragments, and it also can be bands, you can run into a band of soil that ends up having more than 50% rock fragments. You just can't count that towards your treatment. So there are many more kind of nuances to what I'm talking about, but generally speaking, we don't count horizons that have more than 50% rock fragments towards treatment because we just don't have enough retention time. We don't have enough absorption sites. We just don't get good treatment through that portion of the profile. So I wanted to touch on, that's kind of an overview of septic systems, just how this is kind of administered in Minnesota, some key collaborations. We certainly at the University of Minnesota don't do this work on ourselves. Our goal really is having a really strong science-based education program. We do research. We also do outreach. Tomorrow night, for instance, I'm teaching a homeowner education class in Mower County in the Albert Lea area. So anytime we can talk to property owners, that's really valuable because ultimately at the end of the day, they are the ones who are operating these systems. The MPCA has the policy and rules. They are the licensing and certification organization. They also are compliance and enforcement. On a day-to-day basis, this program is implemented by counties, cities, and townships. Those are our local unit of government programs that permit, inspect, and record keep for the over 600,000 systems in Minnesota. We have a large group of professionals, thousands of septic professionals across Minnesota, which include designers, inspectors, installers, service providers, and maintainers, septic pumpers. One of the strengths of our program is all of our local unit of government inspectors all go through the same training and certification program. That doesn't mean everyone knows the same, but it does set a level playing field with a base of scientific knowledge that's used across our industry. You'll see our funding agencies, which is important. We have a lot, we are improving septic system treatment every year in Minnesota, more and more compliance, but ultimately we do have small communities. We have property owners who can't afford upgrades. So you'll see the MPCA, Bowser, PFA, USDA, the Minnesota Department of Agriculture, all have funding programs to help both individual property owners and small communities resolve wastewater problems. And then research collaborators, we've worked with MnDOT, MDH, MPCA on various research projects. So our training and certification program, we train approximately 200 new certified people each year. So we have a class that's called Introduction, the first class people take in our certification program. That's where that number comes from. You'll see in any given year, we're training right around 2,000 people. So some of those are new people, but many of those are coming back for continuing ed. So there's a continuing ed requirement that every 3 years, people have to have 12 to 18 hours of continuing ed. If they do any sort of soils work, 6 of those hours have to be directly related to soil and soil interpretations and soil understanding. So looking at the list of companies on the right, and some of these companies hold multiple certification, but you can see nearly 600 designers. The designers are the ones who are doing the initial soil interpretations for design. Installers putting the systems in the ground. Inspectors are both private and local unit of government also doing soils work. And finally, our maintainers and service providers, right around a little over 500 of those who are taking care of the systems and doing service on them. So kind of looking at the lay of the land of systems, I mentioned things are improving. So this is data from 2007 to 2019, and it's showing compliance. So that's what the green is. So if you can see in 2007, I don't know, 66%. Going to the far right, you can see we're at 81%. So it's not perfect. Not all of our systems are adequately treating wastewater. You'll see there's two categories which are important. The red, which we're now at that 4% amount, are imminent public health threats, which mean the wastewater could be coming in contact with someone. So directly either backing up into their home or directly discharging to the surface or to a lake, river, or stream. The blue category are systems that are failing to protect groundwater. Those are systems that typically don't meet that 3 feet of separation. So we're continually striving to improve these numbers, and this is all based on estimates. Some counties have really good data, but most of the time they're basing it on the compliance records they've received to date, and they just know when systems are looked at, there are certainly a percentage of those that do not pass inspection. So with that, we're going to move into kind of the last part, which is the bigger part of the presentation here, which is just talking about emerging issues and challenges in our industry. I'm going to talk a little bit about COVID-19. Wastewater tracking has been getting a lot of attention lately, so we'll touch on that. We'll talk about small community wastewater treatment and affordability. There's nationally more talk about environmental justice and access to proper sanitation and clean drinking water being something that not all of us have in the US, and really is one of those key things that should be something that we all have, is clean water and sanitation. We'll then touch on contaminants of emerging concern, a little bit our work with chlorides, microfibers, and finally water use and reuse. So first looking at COVID-19, so ultimately there's been work done internationally, certainly in the US and by Met Council, for instance, here in the Twin Cities metropolitan area where I'm living. You can see the image on the right, and ultimately when you are, if you are sick with COVID, whether you know it or not, you are shedding some of that virus in your wastewater. So they are using that to potentially predict how many people within a community, and you can't really equate it, at least to this date, we haven't been able to equate it to numbers, but we can see, are the numbers going up or down? I would say this has particularly gotten more relevant lately when most of us who are now testing aren't going somewhere, aren't getting a test done. We're doing at-home tests, and so we don't actually have a good feel for that. I do want to just highlight that the testing that we're doing is not for active virus, it's just for the RNA. So even though we could be finding this in the effluent coming out of a septic system like I'm going to show, that doesn't mean that that virus is actually it has the ability to make anyone sick. COVID-19 in particular is not a virus that has been found to spread via water. It's been aerosolized. So it's been spreading primarily through respiratory transmission. And that was actually highlighted by a study that was done in civil engineering where they tested well water that was coming out of shallow aquifers in karst areas and from drinking water sources such as the Mississippi River. And they were not able to find active COVID-19 viruses. So really, it's not really being done to show that we're making people sick. It's just being done to kind of be an indicator of how many people within a community may be sick. So the good news for us is that from a wastewater treatment perspective, COVID-19 is very easy to treat. So wastewater treatment plants and septic systems that are designed to treat viruses and pathogens. And COVID-19 is a type of virus that is particularly susceptible to disinfection. Something as simple as a soap molecule disrupts the fatty layer or coat that surrounds the virus. And once the viral code is broken down, the virus is no longer able to function. So if you were happening to have it on your hands, and I remember early on in the pandemic, I was walking my dog and I was going by a garbage can and I had his poop bag in my hand and I didn't know if I should touch the garbage, right? We were afraid that it could be spread via the surface. But the good news again is soap and water deactivates this virus. So we did do a little looking at COVID at rest areas. So this was done, what I didn't know at the time was early on in the pandemic. I think we all thought potentially last summer COVID-19 was done. We didn't know that it had many more years of life left. So we sampled 3 rest areas in May, June, July, and August, and we were looking again for just, is that DNA present? At the same time, we also tested for a chili pepper virus, which is known to be very resistant to breakdown. It's a good indicator of overall wastewater inputs. So we did this work with the DOT, who runs all the rest areas in Minnesota. One of the questions from their perspective, or which had been brought up, and I don't know if any of you remember this, I love going to the North Shore in Minnesota. And there was like conversations like, don't come to the North Shore. Our hospital systems can't handle high level of COVID, right? So one of the things about rest areas is people often stop at them on their way leaving, larger metropolitan areas. And this data didn't carry on long enough to really show that. We looked at it this one summer, and as I mentioned, there was really no interest at the time in continuing it. So we don't have that long term, and we don't really have a good feel. But I think we also all know at the end of the day that COVID kind of made it everywhere over time. It was just trying to slow some of that transmission to some of our more outstate areas. So this just shows one site just to show you the kind of data we were gathering. This is the amount, and it's a log scale on the left. Dresbach is actually a rest area on the border of Wisconsin. So it could have been all those people from Wisconsin bringing the COVID in. And what you'll see, we were measuring what was leaving the septic tank and that what was in a very shallow down gradient monitoring well. So you do see a reduction in the amount, but we do have, this is just the pepper virus. This isn't COVID yet. So what we felt comfortable though is that we were measuring sewage, right? We had evidence. And as far as the pepper virus, why the number is down, there's a couple reasons. One could be treatment as it's moving its way through the system. The other is as it's in that monitoring well, it's also mixing with groundwater. So here it shows the COVID-19 levels. And I do want to point out that, due to how this was measured, its genomic copies, that anything really below that log4 scale has high error associated with it. So you'll see the only really valid sample we had early on in the pandemic. So again, that was May of 2020, showed some pretty high levels, but it would have been interesting because ultimately the early crests of this pandemic were actually pretty low in comparison to numbers later on. I'm sure we would have seen much higher numbers, but as I mentioned, this data collection didn't continue. So I would say what we have found though from COVID as a result of it really isn't directly COVID related. It's really an increase of a lot more people being at home. So 33% of Americans are working from home, and many of those people, like myself, the reason why my cat just knocked over my laptop, right, is because I'm working from home many days out of the week. Most students were at home. Many parents, I have a hard time believing this number actually played out because most parents I know were very happy when their kids went back to school. Many employers, I think because of COVID, but also because of our current workforce, are also realizing that many more people want to continue, if maybe not every day, but many days of the work from home. And so what that means is that more of the wastewater that each of us generate every day is going out to our septic systems, if you're on a septic system. So this has resulted in an increase in service calls, the need to educate people better about spacing out their usage. It's resulted in systems that were getting towards the end of their useful life coming due for replacement. The other big issue is there's also been a desire to move out of the city. Some of that was because of COVID here in the Twin Cities. Some of that was also due to some of the riots and unrest that occurred, that people didn't feel safe. So we definitely have seen an increase, and kind of what got brought up earlier is that many of our septic systems, we have a lot of them, they're also increasing. We're not seeing less septic systems because when we develop new lots, a lot of them are outside the extent of municipal wastewater treatment system, and also therefore need to have septic systems. Another concerning issue is that people are putting more sanitizers down the drain, and ultimately high amounts of sanitizers can be harmful to septic systems. We rely upon naturally occurring bacteria in our systems, and most homes use some disinfectant that's natural, and we can handle a little bit of it. But when people start to kind of push that envelope, we can negatively impact the microbes in our system. So kind of thinking about the difference here between the systems that we have and funding, that's what we're going to kind of look at coming up here next. Ultimately, across the nation, you'll see about 75% of people are in more urban areas. You'll see there's 16,000 wastewater treatment plants approximately across the US. And this is where over 99% of the federal funding has gone, is to those large wastewater treatment systems. When we look at the 25 million septic systems across the US, they are dependent on soil. We view them to be in more rural areas, but keep in mind, for instance, Anoka County has a ton of septic systems. And that to me is not I don't think of that as a rural area. So about over half of our septic systems in Minnesota are around our large urban centers, not within Minneapolis, but think about the Twin Cities metropolitan area, that a lot of people are living around those big urban areas. And certainly there's been a lack of funding targeted, and where we're looking to target that, I was actually on some legislative calls earlier today with federal lobbying that's occurring, is trying to get more of those federal infrastructure funds to help the low income people who truly can't afford a new septic system. A new septic system in Minnesota generally will cost you from $10,000 to $30,000, and that's an out-of-pocket cost. And if you are, below the, the median income, that's where this money is targeted. That bill is something generally you can't afford. So the combination of grants or no interest loans that can be put onto your property taxes are beneficial to help those people. So here is a map of Minnesota showing where the state has collected data about the need for proper wastewater treatment in small communities. So this could be 5 homes, this could be 50 homes. So this is data that was presented, offered by the counties. So you'll see anywhere from 1 to, I think St. Louis County wins at 123 communities. So what the PCA is doing is hoping to actually hire some facilitators. These towns or communities don't have staff, they don't have engineers. So getting through the process of resolving these, and if it was easy, they already would have done it. If they could have put a system on their property, or they could have connected to a wastewater treatment plant, they would have. So for most of these communities, a decentralized solution is going to be the best answer. But we also need funding to help local units of government. We need an increase in low income grant funds. And in general, our state has had a lot of funds, but not enough to meet the need. So here actually shows the Clean Water Fund. So what you'll see is $1,000 each year is available. It's a max of $40,000 per county, which pays typically for 3 or 4 systems. There's been $8.3 million in clean water funds that have been awarded to counties for low income fixes. So that's resulted in about 850 systems. But you'll see that the request overall is 13.5 million. So we're not meeting the actual demand that's out there. So this shows our public investment by year in Minnesota. And I can definitely tell you, with my experience across the US, Minnesota definitely leads the charge as far as how much we've been really investing in improving wastewater treatment. So you can see going from 4 million with that peak in 2017 of 22 almost $23 million. And really a lot of that was, you'll see, really stepped up when the Clean Water Legacy, Land and Legacy Amendment was passed. So, you know, that's 20 years of guaranteed work to help improving our waters, doing lots of things, but improving our water in Minnesota. So this just kind of shows who's administering that money, a bulk of it coming from the PCA, but the Department of Ag, also 55 million that's available, Rural Development 41, Bowser at 18, and finally the Public Facilities Authority, nearly $17 million. One of the big challenges has been, though, is for the really small communities. Ultimately, the size of your community really does impact the cost of wastewater treatment. The larger your community is, or the larger your service area, generally, the lower the cost is. So this is looking at monthly costs over time. And you'll see again that, you know, Met Council being kind of that very large service area has some of the lowest costs. And as you get into those small communities, some of the higher cost for wastewater treatment. So, and many of these small rural communities, when you start getting into those expensive costs of, you know, $70, $80, $90, that's a significant part of people's budget. So with that, we're going to move on to CECs. This is probably a term you've all heard before, but CECs are thousands of chemicals that are produced and used every year. Many of these things are found in the environment. So it could be over-the-counter medicines. So you see cortisone 10. It could be prescription medication. Many things fit into this. So pharmaceuticals, though, and personal care products are the most likely things that are ingested by humans and then are deposited into our wastewater treatment system. So this is definitely an emerging issue and an issue we're looking at both here in Minnesota and nationally to see what's happening with these CECs as they move on through systems. So our current project, we're just wrapping up now. We are finally year 3 of this study, is monitoring CECs. And on the left, we don't have a house, we have a rest area. And a rest area is kind of unique for this. And the reason why it's unique is, one, we don't have laundry or gray water, so we won't have all the personal care products you might have at a house. But the big difference is we have lots of people using it. So we will find a lot of those kind of consumable CECs, right? Things that we put into our bodies. And we should find a lot of them because a lot of different people use it. If you just went to one house, you would just happen to find what they're using. So as part of this research, we're collecting 4 samples potentially, depends on the site, but one is the effluent leaving a septic tank. If they have an advanced treatment system, we're sampling after that. We're taking a soil sample, literally seeing what is potentially absorbing onto the soil interface. And then we're finally measuring that shallow groundwater to see what is making its way through. So unfortunately, we did this at year 1, and Jack, who's on this call, really helped us look at this data. We are not completely done looking at the full data set, which is all 3. So I'm only going to show you one image here just to give you a feel for the data. And if you're really interested in knowing more about how it's moving through the systems, we'll have more data coming out soon. But I just do like to show this because it shows, I mean, each of these is a sample point, right? It's a measurement that was made in these septic systems. So kind of looking at the far left, that is the range of antibiotics. So you can see the concentration can be very low. It's a pretty big range and not as high as something like the pain relievers on the right. But we're seeing a lot of it, right? Less antihistamines, right? Less positive hits for that. The next one are chronic disease prescriptions, and the 10 on the right, that's how many different prescription drugs could show up in that category. Some hormones found at generally lower levels, right? That dot is the median value. Quite a big range on the pain relievers. Just a few plasticizers showing up. These might be more common in homes to find more plastics, but we shouldn't have a lot of plastics and just really human waste. Stimulants, right? Caffeine being in that category, nicotine. And the last one I wouldn't have expected to see necessarily any of, that veterinary medicine showed up in the list of things we were able to monitor for at the same price. But humans aren't using rest areas, so that means people are using some veterinary medicines. So along with this, we're also doing outreach around CECs. So in partnership with MDH, we are providing a course to property owners that talks about CECs. It also talks about what good septic systems and well systems are. So we were doing these in person before COVID. We then went to online, and now we'll be back in person. The one I'm doing, for instance, tomorrow night will be all in person. In 2020, we also had a partnership with MDH to hand out well test kits, which is something more people should do, is actually be testing their wells. And it was a good incentive. The map just kind of shows the locations where we've done trainings in the past. So with that, moving on to chloride. So ultimately, and I'm just hitting the highlights of all these projects because I only have you guys for a little over an hour here. Looking at our chloride budget, so we had an LCCMR project to really look at, on a statewide basis, where is salt being used? So this really looks at how we are finding more and more impaired waters for chloride. And a study was done in the Twin Cities, but the Twin Cities has a lot of roads. So the question was more on a statewide basis, where are we using more of our salts? And ultimately, this is an issue for impaired waters, but it's also an issue for wastewater treatment plants. So more and more wastewater treatment plants are finding that they are discharging wastewater above the allowable level, so the chronic standard for aquatic species. So the first set here is just showing on a statewide basis of all the salt sold in our state, what is it being used for? So you'll see the highest percentage is road salt. 17% there is water softeners. The one that was kind of surprising to me was looking at the amount that's used for fertilizer and livestock waste. So livestock waste and fertilizer is a fair amount of the pie as well. You'll see there's industrial, atmospheric deposition, dust control contains chlorides. So so when you look at this, water softeners are a piece of the equation, and that was some of the conversation around this project is that a source that we need to target? We've been talking a lot about how we can decrease the use of road salt. So the next part of the project, though, was to actually look at wastewater treatment plants, and ultimately from our wastewater treatment plants, where is the chloride coming from there? Because road salt is a very small piece of the road salt equation. So when you look at this diagram, if you're a wastewater treatment plant, and this is across many wastewater treatment plants, this isn't just one, it's estimated that 65% of the chloride from wastewater treatment plants is coming from water softening. So decreasing the amount of chloride leaving your home, if you happen to soften it, could actually be beneficial to wastewater treatment. But do keep in mind, for a given wastewater treatment plant that has an industry, or we'll talk about later, it could be you have a truck washing facility that washing down salt, so that would be an industrial source, could also be a big part of your chloride budget. So some of the outcomes of that project is that water softening is a large source of chloride. If you're softening using ion exchange, which would be our typical water softeners, the less salt, the better. So if you conserve water, if you soften less water, and using demand-based controllers like you see on the right versus older timer controls, really do reduce the amount of salt. Some other outcomes, we need additional research on some of the agricultural inputs. We need chloride evaluation within either an impaired water or with our wastewater treatment plant. You really need to do a more detailed evaluation to determine what are the primary chloride sources and what can we do to get it under the standard of 230 milligrams per liter. Any questions at this time, Jack, before I move on?
Nope, looks good.
Okay. So one of the outcomes or kind of related works to this is some of our work with MnDOT was looking again at, is there a way, so when salt trucks go back after, and this is MnDOT, but these salt trucks exist in all kinds of municipalities. When they wash down those trucks, you don't want salt sitting on your equipment. What you'll see is we started by monitoring what was coming out of those, and you'll see we were measuring concentrations from 4 to 55,000 milligrams per liter of salt, and the standard is 230 of what can be in a lake, river, or stream. When we did that monitoring, we didn't find a lot else in that water. We measured solids, bacteria, metals, VOCs, and found very low levels. So the recommendation after that work was to install a treatment system, though, to reduce the solids and to use that effluent to make brine. So we left the chloride in it because we're still going to keep using brine. That's not going to really change, right? We all want to drive. Well, maybe we all don't. But a typical Minnesotan wants to drive 70 miles an hour down the freeway the day after a large snow event. So in 2020, we installed 2 pilot systems, and they were actually tested during 2020 and now 2021. And we've definitely, there's actually a report on our website where we calculated the amount of salt that was reduced, lessons learned. And what I can tell you is they worked really well. They were really easy to operate, which was really important to MnDOT. They couldn't handle another thing, that had a high level of management. And they had no issues as far as using that treated water to make brine. And the reason why some treatment was needed is we didn't want to clog up the brine, the brine spreading equipment, or also spread that on roads. So moving on to microfibers, which I think was an earlier question. So there are more and more synthetic fibers going down the drain. So you'll see a lot of the fibers we are now wearing, so polyester, spandex, nylon, and acrylic fibers, are shed off of our clothing when we wash them. We all have a lint filter in our dryer. And what I can tell you based on research is more lint comes off in your washing machine than your dryer. A recent study found that over 1,900 fibers are emitted from washing one item of fleece clothing. So that can amount to 250,000 fibers over the life of a garment. So this is an area we do need more research. I think there's kind of 3 areas we really need to be looking at. One is, can we reduce it at the source? Some of that would certainly require public education. Particularly if we want people to install aftermarket lint filters. That's the diagram I have on the right, is something that filters your laundry water. This is not a unique issue to septic systems. Wastewater treatment plants also discharge microfibers to lakes, rivers, and streams wherever they're discharging. Some of it is, again, a vast majority of it is settling out into the biosolids or sludge, but that isn't treatment. It's just removal. And a lot of our biosolids end up on fields, right? So end up on the soil where those microplastics can persist. So public education and filtering would stop a lot of this from going down the drain. The second issue we need more research on is, can we upgrade our wastewater treatment plants and our septic systems to reduce the amount they're releasing? And finally, is there anything we can do to biosolids to reduce the amount of microplastics? So my next question for you all is, in about the last 20 years, in our typical home in Minnesota, how much less water is the average home using? So this is something, again, you can type into your chat box. You can think it in your head. Somebody said 9. Anybody else want to answer? I was waiting for the right answer. I haven't seen it. I've seen a lot of answers, but I didn't see the magic answer yet, which is 22%. So what is this based on? So it's based on 2 studies that were done. So one was done in 1999 and the other in 2016. So that's not quite 20 years, it's 17 years. But the difference between these 2 studies found a 22% decrease in water usage in people's homes. And I say Minnesota, a little bit of the data was from Minnesota, but it was across the US. And one of the more interesting parts of the study to me was that indoor water use did not matter where you live. There was not a statistical difference between water usage in Minnesota and California, which is not what I would have expected. So the fact of the matter is, people like to flush their toilets just as much in California as they do in Minnesota, but outdoor water use was different. I'm only focused on the interior water usage data that came out of the study. So you'll see the 2 biggest reductions were in toilets and washing machines. That was the other interesting social side of the study, is that they really were targeting, they looked at were people, was it feelings, right? Did people really shut off their faucet when they were brushing their teeth? And what they really found was it was highly correlated to water using devices. So low flow toilets and more efficient washing machines were the big driving factors in this reduction in water usage. Another study, this wasn't directly out of the same study, but it's just what I want to point out though, is that when using less water is great, but ultimately what that means is that the concentration of the contaminants in our wastewater is going up. And I don't know if you're familiar with these terms, but BOD is the biochemical oxygen demand. Generally speaking, in the past, we would say that number should be less than 170. But you'll look at a more current study showed, this was again done across the US, that the median value was 216. We've also been definitely seeing nitrogen levels rising. So in the past, 30 or 40 milligrams per liter of nitrogen is pretty typical. And now we're at 60. So what I like to tell people, right, is if you have a low flow toilet, the contaminant, what you add to it, it stays the same. The only thing that changes is how much water is associated with it. So that's why we're seeing our concentrations rise. So what is that? What are the impacts of low flow toilets and front loading washing machines, which I'm all for, is we are going to see as more and more people either we build new homes or remodel older homes or replace old fixtures that flow volumes are going to continue to reduce. We expect to see less than 138 gallons. Concentrations will rise, and we've always talked in our industry about treating gallons. How many gallons? But we can't just think about hydraulics. We also have to think about the overall mass of whatever contaminant we're trying to treat, because as I mentioned, the amount of organic material doesn't change. We still have to be able to treat that all. The other challenge that arises from this is more of a municipal issue, a centralized issue, but we have less water flowing in pipes. So that means things can more easily clog. So my last topic here is about wastewater reuse. So ultimately, as I kind of started this, we are reusing all of our water. It's just a function of how quickly. So the image you see here on the right, not taken in Minnesota, right? This is a picture from California, where they are using treated wastewater to grow grapes. One of the challenges of Minnesota and reuse is that, give or take 6 months out of the year, we have nothing growing. So we don't have anywhere for that wastewater to go. But so where reuse has really taken off is more in some of our more arid and where water scarcity is a bigger issue. And certainly we do know that scarcity due to climate change is anticipated to further impact water supplies. Other reasons we're considering water reuse is just to make water supply more reliable and provide some diversification. It can extend the capacity of existing infrastructure. There are wastewater reuse projects in the middle of San Francisco. There are a few examples in Minnesota. If any of you have been to the new state park at Vermilion, that actually has a reuse system where they're taking shower water and using it for toilet flushing. And it goes through some treatment. And the big thing that they ran into, and this is true of almost every example like that, is that people use a lot more shower water than they do toilet flushing water. So you end up having extra water. So the highest percentage of reused wastewater in the US goes for either agricultural irrigation or landscape irrigation, golf courses. I do know of a golf course in Minnesota that it stores all of their wastewater through the winter in some ponds and then uses it during the summer months to irrigate a golf course. I do want to highlight though that gray water, which a lot of people think about reusing, so gray water would be your non-toilet water, also your non-kitchen sink water. Your kitchen sink carries a pretty high organic and bacterial load, but it's still not clean. It's a lot cleaner than the rest of the wastewater in our house. Obviously, the toilet is the biggest source of viruses and bacteria, but gray water still does need to be treated prior to any sort of reuse, and how much it needs to be treated really depends on the ultimate use of that water. So some of the challenge, the first one I already hit, the first one I didn't. So gray water reuse for even toilet flushing requires plumbing and treatment systems. So commonly where these are being applied is at multi-residential buildings or neighborhoods. Pathogen and organic matter requires treatment prior to reuse. So you can look at the example on the right, that water on the left again can't be directly reused. It has to be treated. The other big challenge is that operation and maintenance of gray water treatment systems is currently not well guided or monitored in Minnesota or most of the US. So this is something we're certainly looking at more within Minnesota, is having more consistency, because it's even as challenging as within the house, that's plumbing, right? When it leaves the house, it can be a septic system, but if it's an interior treatment system, that's considered to be a plumbing fixture and then covered under Dolly. And so state agencies having consistency in regulations has also been a challenge around reuse of wastewater. There are examples where they are looking again at either potable reuse, so could we make water that's actually drinkable? There are areas where they're looking at using treated wastewater to recharge groundwater. So there are lots of examples of reuse occurring, and I think it's something we're just going to hear more and more about in the wastewater treatment industry. So kind of in summary, septic systems are a really important part of our infrastructure in Minnesota. There's a need that exists to assure our Minnesota waters are protected, that we really do need to be adequately treating that wastewater so we're protecting our water resources. As always, there are existing and upcoming challenges in our industry, and I'm one of the team at the University of Minnesota who works on these issues, so I'm certainly not doing this all alone. But what I want to let you all know, and I don't know what all of your day-to-day jobs are, but we have a really great resource at the university. We've been around for over 40 years doing education and research about septic systems, and certainly just know that in the future, if you ever have questions or issues that arise, we do offer a lot of training too, if it's something you're interested in learning more about that's more geared towards, gaining certification, learning more about how we design and install septic systems. And I didn't really get a lot into this, but this industry is booming and needs people. There's certainly in certain pockets, particularly of the US, a certain need for more professionals in this industry. So if that's something you're interested in too, you can always reach out to me. So our website there at the top, which is the image on the left, and then my email is there as well. And with that, I'm happy to have a discussion here, answer any questions that may have arisen. So.
Well, I don't see any questions in the chat right now. It was a very thorough presentation. That's great. I know when I was first working with you, I hadn't known much about such things, and now I see them everywhere that I go, and I'm like, oh my gosh.
That's what I always tell people. You'll never be able to not see a mound system again. My husband even points them out on trips. So
I think all the wetland delineators on the call can start to use location of lots of mound septic systems as a secondary delineation tool of where all the wetlands are. Well, I have a question for you, I suppose. With all the CECs and things being transported through the waterways, what do you think is the next big advancement for water treatment, particularly in all these really wet areas?
Oh, that's a really good question. I honestly think we're a little far off from regulating any CECs. I'm actually, if I were going to say the issue that relates to that I'm most concerned, it's about how climate change may impact our soil conditions. So if we see wetter conditions in particular, we may see, and rising water tables, we may see systems not as adequately treating wastewater. And what we know to date is that septic systems do remove many emerging contaminants. It just depends on the chemistry of the contaminant, and some of it's going to make its way through. Do keep in mind that we're measuring these contaminants at trace amounts. If I had to really think about the next contaminant though in Minnesota that I think we might regulate at and design for maybe at a different level, it might be phosphorus. So we have a lot of septic systems in sandier soils around lakes, and soils in general are pretty good at absorbing phosphorus, but they have a limited capacity, and sandy soils generally have the least based on the mineral makeup of that soil, the surface area of that soil. So I know there's a county in Michigan, for instance, that now is regulating septic systems around lakes. And currently, how we really deal with phosphorus is just by having a setback, right? We have we have our 3 feet of soil, and then we have a horizontal setback. How well that horizontal setback protects that lake river stream is going to be very debatable. If it's moving under saturated conditions towards that lake river stream, there may be very little phosphorus treatment actually occurring as that water is moving laterally. So I don't know that phosphorus is not an emerging contaminant, but I think about our water resources, and that might be an area we might look at. And I think it could actually be locally driven, particularly when you have some of the soil conditions which really are more limiting to phosphorus treatment.
Questions? Okay, I hear that there's a question and answer section of the chat that people have been using, and I do not see it. 3 dots at the bottom.
I did just see a question about composting toilets show up, though.
Okay. Sorry
Do you
about that.
want to read that
everyone.
one, and then we can maybe see if there's some
Yeah,
others.
so what is the legality of composting toilets, for instance, near wetland or saturated soils, or holding tanks long-lasting in saturated soils is the follow-up.
So composting toilets are a plumbing, I'm assuming you're turning to an interior composting toilets versus an outside privy. So I'm going to talk about both of those quick. So composting toilets inside homes actually do not meet Minnesota's plumbing code because they do not have a water gap to prevent gases from coming back into the home. And some of those gases can be, I don't know, toxic, hazardous. Hazardous is probably the right word at certain amounts. So that doesn't mean some composting toilets aren't used in Minnesota. If they are used, if you do not have the toilet going into your system, you're allowed to make your soil treatment system smaller. Most of the parcels I know that have composting toilets have them because they don't have running water. So that's how they're really dealing with their toilet waste. Because our composting toilets are not they're not managed at the level to make regulated biosolids that they're still harmful viruses and bacteria, so it still needs to be treated. What our septic regulations say, it's still considered to be septic and needs to meet the same requirements as when you would pump out a tank. Because to really verify all the viruses and bacteria were killed, you need to be doing high temperature composting to kill that off, and that's not what most people are doing in their homes. So it's kind of, I would hate to say it, it's both not allowed and a gray area. Because the plumbing code isn't in effect statewide, but it's not enforced statewide. So holding tanks are a legal option. They're really, to me, only applicable or make sense is if you have a facility with either really low water use or very infrequent usage, because all a holding tank means is that you pump it out every time it fills up. But if you have a parcel that can't support a septic system, that's typically why a holding tank is installed. So that might mean weekly or monthly, someone comes by and you pay them, depending where you live, $200 to $500 to pump that tank. So it really leads people to be very conservative in their water usage. And so that takes a special kind of living, I would say, for most people. So they are legal. As far as outside outhouses or privies, they are legal in Minnesota. You have to have if you dig a hole in the ground, you have to have 3 feet below it, which most of our sites wouldn't allow to dig a hole and have 3 feet below it. But if you did, you could do that. More commonly, what's done when people have a modern outhouse is that they just put it over a holding tank, that they literally put their outhouse and they sit it over a tank. And when that tank fills up, they have someone come and pump it out.
Great. Okay. Well, I think that's all the questions I can see. So really appreciate you coming in and giving us this presentation. I think it's a unique topic and an important one.
Yeah, thanks for having me. And if you have any follow-up questions, you guys all have my email, so feel free to reach out.
Great. Okay. Well, see everyone later. Thanks, Sarah.
Thank you.